So this lesson is I can convert degrees to radians, and then we'll switch it back to radians to degrees, and then we're also going to find the arc length using radians. So we've already looked at finding an arc length, but that was with degrees, and it's just a different formula, but it's pretty much the same thing. Okay, so here's the first thing that we need to talk about. So this is an angle in standard form. You can see that measure theta right there. Remember, that's the Greek letter that just stands for an angle measure. And then we'll talk about some other things. So right here, this is called the initial side. Initial meaning like beginning. So anytime we talk about standard form of angles, the initial side is always the x-axis. And if you'll notice, you're always going to go this way, so it's going to be counterclockwise. So the other ray that makes up the angle, that's called the terminal side. So anytime you see the word terminal, that means the inside. And then we're always going to go in a counterclockwise rotation. That's going to give us a positive angle. So that's why you have the green arrow. And then the last thing is if you ever see an angle going in a clockwise rotation, that's going to be a negative angle. So there are such things as negative angles, and if you go take pre-cal, you'll study this a lot more and see why this is useful. But for right now, all you need to know is the vocabulary. So the initial side is the x-axis, the terminal side is wherever the angle stops. If you're going counterclockwise, it's a positive angle measure, and if you go clockwise, it's a negative angle measure. Okay, so we're going to start to build something called the unit circle. So we'll look at that more in a later video. But for right now, if you'll look at this picture that we have, remember that the x-axis is where you're going to start. So right here is your starting dot. And then if you move to the next quadrant, that's going to be 90 degrees. The next one's going to be 180. The next one's 270. And if you go all the way back around, that's 360. So this point right here, you can either think of it as being 0 degrees or 360 degrees because they're basically the same thing. Alright, so the most common unit of measure for an angle has always been degree. You've always had to put your calculator in degree mode when you're talking about angles. And a degree is equivalent to 1 over 360 of a full rotation. So like every degree you go up, it's 1 out of 360. So if you go all the way around, there's no way I can make 360 dots, but you get 360 degrees. Okay, so when we talk about trigonometry, we only talked about right triangles up to now. But actually, you're talking about triangles within circles. So, triangles are measured in degrees, but circles are also measured in degrees, but we also can measure them in a thing called radians. So, let's see if this makes sense. A radian is a unit of angle measure based on arc length. So remember, arc length is like a portion of the circumference or the pizza crust, whatever you want to think of it. 1 radian is defined as the measure of an angle formed when the radius is equivalent to the length of the intercepted arc. Here's what that means. Here's your radius, and it's equal to the intercepted arc. Okay? So remember that anytime we do circumference, that formula is 2 times pi times radius. So therefore, you get this little formula. 360 degrees is equal to 2 pi radians. So if you go all the way around a circle, that's 2 pi radians. And then just common sense, if you had 180 degrees, that would be 1 pi radians. So radians and degree are pretty much the same thing, and you can work from degrees to radians or radians to degrees, and here are your two formulas. So if you want to convert from degrees to radians, you're going to use the left-hand formula. And then if you want to convert from radians to degrees, you're going to use the right-hand formula. And we're going to look at some problems, and I'll let you try it in just a minute. It's pretty easy, I think. So we're going to convert these to radian measures because that's pretty easy right now. So all you have to do, number one, you're going to take the degrees, so 60 degrees, and you're going to times it by pi over 180. Really, all you have to do is convert 60 divided by 180 to a fraction in your calculator. So put that in your calculator and do math enter, and then you're just going to put pi beside of it. So when you convert 60 to over 180 to a fraction, you get 1/3. So my answer is just going to be pi over 3, or 1/3 pi. And that's how you do this. Pretty easy. Alright, let's do another one. So we have 120 degrees. We're going to times it by pi over 180. But really all we're going to do in the calculator is 120 divided by 180. And you're going to do math enter, and then you're going to put pi on top. So this is going to end up being, oh, why did I put 120? Hold on, let me fix this. I can't read. That's 160. Okay, now when we do this, we get 8 pi over 9. And then last one, we're going to do the same thing. And so we're going to do the same thing. So 330 times pi over 180. But really all you're doing in the calculator is 330 over 180 and math enter, and then putting the pi on top. So for this one, you get 11 pi over 6. If you had written it like this, that's the same thing. It's just this is how you'll see it in higher level math courses. So if you can just start writing it like you're going to see it, then that's cool. If you're not planning on taking pre-cal, then that first one is fine as well. Alright, and now we're going to convert from radians to degrees. So, just so you understand, I know that these are in radian mode because they have the pi symbol in there. So, just make sure that anytime you see the pi symbol, you should automatically know it's in radian mode. And I think these are actually easier. So, you're going to times these by 180 over pi. The pi's are always going to cancel out. So, really what you're going to do is 5 times 180. And then you're going to divide it by 18. So you can do that all together in your calculator, or you can do it one at a time, really whatever you want to do. But when we do this in our calculator, you get 50, and that's 50 degrees. Same thing with the next one. I'm going to times it by 180 over pi. The two pi's are going to cancel out. So I'm going to do 11 times 180, and then I'm going to divide it by 9. And you just type that in your calculator, and that one is 220 degrees. Last one, same thing. I'm going to times it by 180 over pi. My pi's are going to cancel out. I'm going to do 7 times 180, and then I'm going to divide it by 3. So this one's going to be a pretty big number, and that's totally fine. So this one is going to be, oh goodness, I made a marijuana joke, 420. Bad example. Okay. Anyways, moving on. So remember, to convert them to degrees to angles, you times by pi over 180, and to convert them from radians, I said that wrong, didn't I? To convert from radians to degrees, you're going to times by 180 over pi. Alright, so I want you to hit the pause button, and I want you to try these by yourself, and if you get stuck, then hit the play button, but try to figure it out for yourself. So pause it in 1, 2, 3. Alright, so the first one is in degrees. I got to convert it to radians, so I got to times it by pi over 180. Remember, all you're doing in your calculator is 45 divided by 180, and then putting pi on top. So this one is pi over 4, and that is in radians. You can write the word radians, but you don't have to because you got the pi symbol, so you know it's radians. And then the next one, the pi's cancel out, and then all I have to do is 3 times 180 divided by 4. And I got 135 degrees. Alright, so hopefully that makes sense. So now let's move on to arc length. So this is just like the previous arc length formula we used, except that we are now using radian measure instead of degree. The formula is actually a whole lot easier, I think. So it's S represents the arc length, and it's going to be r times that angle theta. So r is the radius, theta is the radian measure, and s is the portion of the circumference. So you're looking for this portion. How long is it? Alright, so I'm going to write the formula again over here. So S equals R times theta. This is really nice. So all you have to do is 5 pi over 6 times 3. That's literally it. Alright, and I got about 7.9 if I round to 1 decimal place. If I left it in terms of pi, that would be 5 pi over 2. So remember, when you leave it in terms of pi, you just have pi in the answer. This one, same thing again. So S equals R times theta. So I'm going to do 3 pi over 2, and I'm going to times it by 0.5. So I got approximately 2.4. But if I left it in terms of pi, that would be 3 pi over 4. So remember that these are equivalent to each other. So just knowing which one they're looking for. Okay, this one's a little different. So hopefully you can spot it. This one is measured in degrees. So what we could do is we could do like 15 over 360. And then times it times 2 times 8.4 times pi. Or we could take that degree measure and convert it to radians. Either one is correct. So you get approximately 2.2. Or if you left it in terms of pi, that would be 7 pi over 10. Alright, I want you to try these two. So hit the pause button in 1, 2, 3. Alright, so I wrote down how you're supposed to set these up. And then you're just plugging them in a calculator. So for the first one, I got approximately 39, and then the last one, approximately 3.8. And then, so I wanted to show you a question that they like to use on the final exam. So the central angle theta in a circle of radius 6 meters has an intercepted arc of 10 meters. Find the measure of theta in radians and in degrees. So sometimes they don't actually say that you're looking for the arc length, but you're talking about a circle. It has a radius of 6. It has an intercepted arc length, so the arc length is 10, and you're trying to find theta. So you have to use this formula, and then you just work backwards. So this time it's giving you that the arc length is 10. It gives you that the radius is 6, but you don't know what theta is, but basic math, you should know how to find it. I get rid of multiplying by 6 by dividing by 6, so really all I have to do is figure out what 10 divided by 6 is. So that's 5 over 3 radians. The question also asks for in degrees, so then I would take 5 over 3, and I would times it by 180 over pi, and that would give me 95.9 degrees. So that's the whole gist of this lesson, being able to do this problem. I can find the arc length, I can convert from radians to degrees. I think it's pretty easy. There's going to be some problems on haiku, so let me know if you have trouble. Send me an email, shoot me a message through Remind. We'll try to figure it out. Alright, thanks guys.